Hello everyone, today I'm going to be going over homework 5, recursive function. So let's jump to problem 1. Problem 1 deals with computing like the greatest common divisor, but we have to use recursion to answer this. And so we want a method that's it's called GCD, that passes two parameters, m and n. And then this is like the case where it should happen of how to produce the recursive method. And so we're saying like when we do the m modulo n is 0, then that means the greatest denominator is n. But if it's not, then we just have to keep doing it. And that's how we do it. So let's go ahead and just get into code. So these are the two variables, m and n, both type int. This is where the user inputs the two numbers that we ask them to give us. And then this is what we say m for m and n. GCD is, and then this is where we recursively call this function, get GCD. And so when we take a look at it, we pass in two numbers, two ints, and I'm going to skip this explanation for now and jump to this because this explains what we do here. So how I kind of interpret it's like, let's keep calling get GCD and do the modulo m modulo n. And the aim of this is to essentially keep getting the second number, which would be n, close to 0. And when it is 0, then we can just return it, m being that case. And that will help us find the greatest common divisor. So again, this is like the stop condition of recursively calling the function. So let's go ahead and just give a couple of numbers, say 100 and 5. It should be 5 because 5 is the biggest one for the greatest common denominator, so that's correct. So now when we go into problem 2 talks about, basically we're going to ask the user, can you just give me a number, and I'm going to reverse it to you. And when we do, we're going to give the reversal. So if they give us 1, 2, 3, 4, 5, then we just display 5, 4, 3, 2, 1. Okay, great. So how does that look like in code? Here we have a value. We tell, hey, can you give me a number, and I'll reverse it for you. This is where the user inputs its value, and this is where we call the reverse display value. And in this case, I have two variables. I'm passing the int value, which represents the user's input, and then I have answer equal to 0. Now I use this because this kind of helps me keep track the number like per iteration. So in this case, just like if the value is equal to 0, then we just return answer. And remember, answer is what's keeping track of each iteration. And so if value is not equal to 0, then we're just going to go into this condition, and where we have essentially int a equals to answer times 10, and then int b equals value modulo 10, and then we actually add those two together to get answer. Okay, great. So what is the purpose of A and B? A just helps us keep track of the last digit for each iteration, while B just helps us to represent like the last number of the last digit of that number. And when you combine it, that gets me the answer. And I did a couple of print statements just to keep track of what was being updated. And so then we have reverse display. This is us actually recursively calling this. Now I did value divided by 10 because if you think about it, decimal, right, decimal, it's base of 10. So like if you have like 321, for example, you have for 3 to get to the 321, you have to do 3 times 100 plus, and then 2 times 10, that's the 20, and then 1 times 10, that's the 1, and then if you add them all up, you get 321, right? And then answer just helps us keep track, like I mentioned. So we talked about 321 a lot, so let's do 321. We should get back 1, 2, 3, and we got back 1, 2, 3. Awesome. Okay. Problem 3 basically talks about, hey, can you go ahead? I'm gonna give you like a decimal number, which is like base 10, but can you turn into a hex number and return as a string? Hex number is base 16. And so I have the int user value, and then we have the hex equivalent, and basically I ask them, hey, can you give me a decimal number? And I will store that into user value and pass into decimal to hex, and then I'll translate it into a hex equivalent and I'll display it right here. Okay, what does decimal to hex look like? Well, I pass a variable that's an int type, and like I mentioned, 16 hex is a base 16, and so again, this is like the stop condition. We only stop if the value is equal to 0, and then it will just return nothing. But like, let's say like the value is like less than 0, that means it's a negative, so just place like a negative in front of the value, and then it returns as the negative. That was just me doing like extra credit. But all right, here's actually us doing it. So before I get to this, I want to explain what the hex decimal looks like. So, you know, if it's 0 through 9, then it should return that, 0 through 9. But if it's like, for example, 10, it should return A. If it's B, it should return 11. Or sorry, if it was 11, it should return B. If it's 12, return C, and etc. up until 15. Okay, and that's base 16. So only 10 through 15 gets letters and everything else gets numbers. And so I have a switch case that handles that. Okay, so you know, hex equals, if it was value equals 10, then return A. And hex is actually what we're going to return this whole function, because this function actually returns a string. And so the hex represents the string. Okay, so now let's go ahead and explain this part of the code. And so essentially, so how you kind of would do it is essentially you have to do the value modulo 16, and then that is the remainder. You want to store as remainder, and then keep a track of that. If the remainder is less than 10, then we have to toString and add it to hex. Okay, and then this line of code is basically saying, hey, grab the value, divide by 16, and then keep calling this function until this condition is met, this condition is met, or this condition is met. So then we can return hex. Okay, so like if you think about it, we'll do an example. Like if I were to give the 45 as a decimal number, and we wanted to return a hex number, and the hex number that's 159. To do that, we just do 345 like modulo 16, and then that would give us 9, and then we just keep doing the modulo of that to 16, and then we'll find out that's going to be 5, and if we do modulo of that, it's going to be ended up being 1, and then so essentially it's going to be 159. That's the hex number 4345. So let's test that out in code. 345, and then it should be 159, which is correct. So I can go back to problem 3. That was problem 3. Now problem 4 is interesting because it's the 8 queen problem. So in chess, there's a queen, so it can tag like straight across, up and down, and diagonals, both left and right diagonals. And so you're given like a chessboard that's like 8x8, and you're gonna place like 8 queens on it, and you have to make sure like none of the queens attack like each other. And you know, that's what we're gonna try to do. So here I went ahead and created a board, and board is a 2D array, and the aim of board is to create the board, aka like initialize it. I'll go ahead and show you what that looks like. So to initialize it, we have to first initialize like an 8-point row like pointers, and then we also have like pointers for like each column. So when this is what that does, it's like assigns like 8 row pointers, and then we have like a for loop and then another for loop and nested. First for loop is like for the row, and then the second one is the column. And again, this is us assigning a pointer for the 8 columns inside of the rows. And then this second for loop, the aim of this is to initialize each single like tile to be like a blank space. So in the case later, you'll find that if we'll update this exact code, this line, to instead of a blank space to a Q stands for queen when we actually place a queen. So that's what create board does. And so now that's what create board. We only do it once. Like there's no need to keep calling it. You just create the board once. And then this part is when we actually do the recursion. Recursive queen takes into essentially functions into consideration when we look into it, but we'll look into how exactly it is being worked. So essentially, this first parameter is the current row, and then the second one is a 2D array that represents the board here. So for this recursive queen, it's a Boolean function that we have passed in the current row and then the 2D array board. And since it's Boolean, it will return like true or false. Now, if it's true, then it will print a board, but if it's false, it's just gonna ignore this. And print board, it's pretty straightforward. This is us like just printing the board if it has like queens or blank spaces. That's what just this does. So that's not that impressive. So let's go ahead and look into recursive queen, since it's a Boolean and it uses like a couple of functions. So like I mentioned, you get passed in a current row and a 2D variable called board. So this where we're gonna say, hey, so this is kind of like the stop condition. So current row, if current row is 8, then we're gonna say it's true. That means we're at the end, we're good, we just need to print the board. Okay, but we're not gonna start at 8, we're starting at 0, so we're starting at the top, so it skips this, and then we go straight into this for loop. Okay, and in this for loop, we're gonna loop through the columns, and since it's an 8x8, so that means it has 8 columns, we're gonna go into it, and we're gonna first see if we can place the move down. So is valid move is a function that takes in the index, the rows index, the columns index, and board. And the point of this really is just to see if when we place that queen, is it valid? So it's going to return a Boolean value. When we place a queen there, it has to check for 3 conditions. 3 conditions are if there is a queen on that column, or is there a queen tagging from the left diagonal or right diagonal. So this first for loop checks to see if there is a queen in that column. If it is, we cannot place it there. Okay, and that's me actually like looping through to check to see if there's a queen there. Now, like I said, if the Q is there, okay, queen is in that column, then return false, you can't do it. Okay, so this one is basically the basically just checks for the left diagonal attacks. So it's gonna loop through. So originally for these two for loops, I did like create like 2 for loops, like one for loop and nest in this one, another one nested in this one, but I find that actually it further complicates it. So simultaneously in both of them, because they're basically the same, this one is checking for the right diagonal text, this one's checking for the left diagonal checks. So I basically simultaneously check the row and column. And so if for being an upper left diagonal, I just have to keep checking from the index in the rows, index, and column that I was given and subtracted for 1 for each index to check for a left diagonal. Now, in the case that there is one, it's going to return false, and then keep with the iteration where it's going to both decrement I and j until both I and j are both you know, essentially less than 0. Because if it's not, then it'll break out of it. And that's the same thing really with this one. That's the name for that. Except since this one's checking for the right diagonal, instead of decrementing j, which stands for the column index, we're going to increment it. And the condition looks different. But essentially, the if statement is pretty much the same. If there's a Q, which means stands for queen, that means nope, don't do it, you can't do it. And it returns false. But the way that this condition stops is that, I mean, this one is the same thing. I can literally write less than -1, and it's literally the same thing. Same condition, except the only thing that's different is my j's, because since this one is being incremented, because it's checking for the right diagonals, and as you go to the right, the column increases, and so we have to stop at 7 because it's 0 through 7, which is 8 columns. If it's at 8, and it just breaks out of the loop. And then if there is no queen in the right upper diagonal, no queen in upper left diagonal, and no queen on the in the column, then it returns true, and it's saying, hey, that is a valid move, so you're good. That means you can now place the queen, and that is a separate function where I just say, hey, just pass me a row index and a column index in the board, and I'm going to update and put a Q there. Okay, and then after that, then this is where we recursively keep calling by incrementing the row. Now, in a case it doesn't work out, we're in that column, you can't place a queen there, we have to do something called backtracking, which removes the previous queen from the previous row, and that's what this line just does. And remember how I said when we initialize it, we set it to a blank space? That's why, you see this line? That's why here we did the same here when we set it to a blank space. And then, but in the case where we no longer have to backtrack, and this is true, it just keeps incrementing to the row is 8, and then it breaks out of it. But once we get a true recursive queen, then we actually print the board. In this case, I already ran it, and we can check to see if it worked. So 0, 1, 2, 3, 4, 5, 6, 7 rows. 0, 1, 2, 3, 4, 5, 6, 7. That's 8 columns. This queen is not attacking anything, and then this queen is not attacking anything. Yes, that's good. This queen is not attacking anything. Good. And then this queen also not attacking anything. Yep, that's pretty good. And you can keep checking for yourself, and none of the queens are attacking each other. So yeah, that is pretty much it for homework 5.